Hey guys, so for this lecture, I'm going to introduce to you vectors. Knowledge about vectors is important because many quantities used in physics are vectors. You cannot simply add or subtract these quantities without taking into account its direction, or you'll get incorrect results. Let's start first by discussing scalar quantity. So when you say scalar quantity, so this is one that has nothing to do with spatial direction. So each has a scale or size, but no associated direction. So meaning, for this case, it is purely magnitude. So many physical concepts such as length, time, temperature, mass, so we have density, charge, and volume are considered scalars. Another example is the number of students enrolled in your class, let's say. So let's assume that we have 40 students enrolled in our class. So this quantity does not have any direction, but it is being described by this magnitude here, which is 40. On the other hand, vector quantity is one that can be specified completely by both its magnitude and direction. So many physical concepts such as displacement, velocity, acceleration. So we have some other more. We have force and momentum as well, which are example of vector quantities. So a vector quantity can be represented by an arrow drawn in scale. So let's say 20 newtons to the right. So you can draw this your 20 newtons as shown here. So let's say this is your vector A that represents your force. So your vector starts with a tail and ends with the head. So this is the tail of your arrow. Then this is the head of your arrow that refers to the ending point of your vector. So it can also have a angle. So let's say 20 newtons uh, with a certain angle here, let's say 5 degrees along the horizontal. So still, this is being represented by your arrow starting at this point up to the tip of your arrow. So they are usually written in bold face, or sometimes you also uh, represent your vector as a letter as, with an arrow above it. So when we say resultant in vectors, so this is the sum of the number of vectors of a particular type. So let's say you have a group of vectors, uh, vector f, let's say, and we want to get the summation of these vectors as long as they are of the same type. You can get the resultant vector. And like, for example, a force vector added up together, taking into account both the magnitude and direction. So by doing so, we can get the resultant. So this is also described as a single vector that would have the same effect as all of the original vectors together. So you represent a group of vectors of a particular type as a single vector. Okay, so finding the resultant are of several vectors. So let's say we have three vectors, a certain vector A shown here. Then we have vector B. Then we have a certain vector C, let's say going to the left. So we can get the resultant of this using graphical addition of vectors or polygon method. So by drawing these vectors into scale and in the proper direction. So polygon method looks like this. So we have your vector A here. Then you will have your vector B here. Then vector C. Then the one that will close this one. So this is the starting point of vector A. This is its tail. Then we have the tip of your vector C. We can close this polygon by drawing this vector here, and I will call this vector my resultant vector. So a polygon method in physics is actually the extension of triangle law of vector addition. So this law states that if a number of vectors can be represented by the side of the polygon in magnitude and direction, taking in order as shown in our drawing here, so we have three vectors, then their resultant is represented by the side which close the polygon, taking in the opposite order. So this one is the resultant vector using this polygon method. Now, for adding two vectors, the resultant of two vectors acting at any angle may be represented by the diagonal of a parallelogram. So that's why the name of this method is Parallelogram Method. So let's say we have vector A. So let's say this is vector A. Then we draw these two vectors. So we have another vector B, so that their initial points, which is the tail part of our vector, coincide. So if this is your vector A, let's say we have another vector here, which is your vector B. Then we draw lines to form a complete parallelogram. So for this case, let's try to trace the diagonal of our parallelogram. So let's say this is your resultant vector R. Then we can close our parallelogram as shown here. So I know this is just a rough sketch, so sorry for that. So that's it. So the diagonal from the initial point to the opposite vertex of the parallelogram is the resultant.